Okay, we're going to find the volume of the solid whose base is bounded by the functions 2x squared minus 2x, which is this curve right here, this parabola, the line y equals x, which is this line right here, and the vertical line x equals 1. So that's the base of the solid, and if we slice the solid perpendicular to the x-axis, so this way, then the cross sections are squares. So to get a better feel for what that looks like, we can use this applet here. And so as we see, here's our base. If you just look at it from looking down on it, you see that it just looks like our base. But if we rotate this up, we see that each slice would be a square. Okay, so this is what the solid looks like from all the angles. And we're going to try to find the volume of this object right here, this solid right here. Okay, so the important thing to realize is that when we slice it, each one of these slices is going to be the bottom of a square, and erected from there is going to be the square. Okay, so let's go back and actually compute this. So let's realize that the important thing to find here is that the distance between this line and the parabola is going to represent the base of the square. And if I want to know the area of a square, I just take the base and I square it. So if I were to draw a line right there, imagine that's actually touching the line here, sorry. So this is going to be so this line here is going to represent the base of one of these squares. So how do we talk about how big this length is? Of course, it's going to depend on where we are on the curve, or where our x value is. So if I'm over here at a smaller x value, I'll be over here. Larger x values, I'll be over here. And so of course these lengths are all different. But in general, we see that the distance between the line and the parabola is just the distance from the line to the x-axis, which is just x, minus the line from the parabola to the x-axis. So the distance between the line and the parabola is given by x minus the parabola, 2x squared minus 2x. So if I want to find the area of a square whose base is one of these line segments, it's just going to be this segment here squared. So this is the area of one square. So to find the volume of this solid, it's going to be, I'm going to integrate from my bounds. My left bound is 0, my right bound is 1 of this area function. So this is going to be x minus 2x squared minus 2x quantity squared. We can distribute this negative sign, and inside this parentheses we have x minus a negative 2x, so it's x plus 2x, or 3x minus 2x squared squared. So dx. Oops again. Sorry for that little line. Okay, so we can now expand this out by foiling. So we get 9x squared minus 12x cubed plus 4x to the fourth dx. Okay, so the volume is going to be this integral. So using the fundamental theorem of calculus, we can find the antiderivative, which will be 3x cubed minus 3x to the fourth plus 4/5 x to the fifth. We need to evaluate that between 0 and 1. If we do so, we'll get a value of 4/5. And that's the volume of that solid. And just so you can, you can check your integrals using your graphing calculators. If you use the function, I found this under Math 9, there. And then I entered the function 3x minus 2x squared quantity squared. The comma, the variable is x, comma, the lower bound 0, and comma, the upper bound is 1. And we see we get 0.8, which of course we can convert that to a fraction. See, it's 4/5.